Hello all. In the last few classes we were discussing about SQL commands. And today we will focus on database programming techniques. And we can say that there are different methods that have been developed for accessing these databases from programs. And most database access in practical applications is accomplished through software programs that implement this database applications. We will be discussing about this database programming techniques, embedded SQL, stored procedures today. So I told you that, we'll first discuss about this database programming. So we have different software programs that implement this database applications, and this software is usually developed in general purpose programming languages, and that is known as a host language. And examples for these languages include C, C++, Java, or COBOL, etc. And we have database languages also like SQL, and they are known as data sub languages. And why we have this kind of database programming techniques, and we can say most database systems have an interactive interface where this SQL commands be typed directly into a monitor for execution by the database system. For example, in a computer system where the Oracle RDBMS is installed, a command SQL plus starts the interactive interface. Okay. The user can type SQL commands or queries directly over several lines ended by a semicolon and then the enter key. Then alternatively, a file of commands can be created and executed through the interactive interface by typing this file name. And this system will execute the commands written in the file and display the result if any. Okay. So we can say that this interactive interface is quite convenient for schema and constraints creation. But in practice, the majority of database interactions are executed through programs that have been carefully designed and tested. So these programs are generally known as application programs or database applications. And we have another common use of this database programming, that is to access a database through an application program that implements a web interface. For example, when making airline reservations or online purchases, etc. So for all these purposes, we have this kind of programming. And we have different approaches to this database programming, and several techniques exist for including database interactions in application programs. And the main approaches for database programming are the following. So we have embedded commands and then library of database functions, or a brand new full-fledged language. Okay. So the first one is embedding database commands in a general purpose programming language. And in this approach, database statements are embedded into the host programming language. Okay. But they are identified by a special prefix. For example, the prefix for SQL is the string XS SQL, that is EXEC SQL, which precedes all SQL commands in a host programming language. And we have a pre-compiler or a pre-processor that scans the source program code to identify database statements and extract them for processing by the DBMS. So they are replaced in a program by function calls to the DBMS generated code. And this technique is known as embedded SQL. Okay. So we have a general purpose programming language and we can embed this SQL statements within that. Okay, that is embedded commands. And how we distinguish them, or how can we distinguish embedded commands? That is in the case of SQL, we have EXEC SQL, that is the pre-compiler, or we can say this Preprocessor will identify that it is a database command and that will be handled separately. Okay. And the second technique is that we can use a library of database functions or classes. Okay. So a library of functions is made available to the host programming language for database calls, and that is known as this application program interface or API. For example, there could be functions to connect to a database, prepare a query, execute a query, or execute an update, loop over the query result on record at a time, and so on. And the actual query and update commands and any other necessary information are included as parameters in the function call. And this approach provides that what is known as this API or application programming interface. And the third one is that we have we can design a brand new language. Okay, that is a database programming language designed from scratch to be compatible with the database model and query language. And here it actually minimizes the impedance mismatch. In practice, the first two approaches are more common since many applications are already written in general programming languages but require database access. The third method, that is developing a brand new full-fledged language, that is appropriate for applications that have intensive database interaction. Okay. So one of the main problems with the first two approaches is that it is having impedance mismatch, okay, and which does not occur in the third case, that is developing a brand new full-fledged language. So this minimizes impedance mismatch, and we'll see what is meant by this impedance match. So this is a term that is used to refer to the problems that occur because of differences between the database model and the programming language model. Okay, that is incompatibilities between a host programming language and the database model. For example, we have the practical relational model has three main constructs, that is columns corresponds to attributes and their data types rows, or we can call it as tuples, and we have the tables, that is sets or multi-sets of records. The first problem that may occur is that the data types of the programming language differ from the attribute data types that are available in the data model. So it is necessary to have a binding for each host programming language that specifies for each attribute type the compatible programming language types. Okay. So this is a type mismatch or an incompatibilities requiring a new binding for each language, and which means a new binding or a different binding is needed for each programming language because different languages have different data types. For example, the data types available in C or C++ and Java are different, and both differ from SQL data types, which are the standard data types for relational databases. Okay. So another problem occurs because results of most queries are sets or multi sets of tuples or rows, and each tuple is formed of a sequence of attribute values. So in the program, it is often necessary to access the individual data values within the individual tuples for printing or processing. That is the case with a program. Okay. So hence a binding is needed to map the query result data structure, which is a table, to an appropriate data structure in the programming language. Okay, so a mechanism is needed to loop over the tuples in a query result in order to access a single tuple at a time and to extract individual values from the tuple. So the extracted attribute values are typically copied to appropriate programming language variables for further processing by the program. So a cursor or an iterator variable is typically used to loop over tuples in a query result. So individual values within each tuple are then extracted into distinct program variables of the appropriate type. Okay, so that is we'll be able to use this kind of iterators or cursors to access individual tuples or individual values within each tuple. So now we'll see steps in or typical sequence of interaction in database programming. So when a programmer or software engineer writes a program that requires access to a database, it is common for the program to be running on one computer system while the database is installed on another. Okay. So in that case, what we need to do, we need to have something like a client server model, and where a top tier client program handles display of information on a laptop or mobile device, usually as a web client or mobile client. A middleware application program implements the logic of a business software application but includes some calls to one or more database servers at the bottom tier to access or update the data. Okay. So when writing this such an application program, common sequence of interaction is following. That is, client program opens connection to the database server. Okay, so when the application program requires access to particular database, the program must first establish or open a connection to the database server. So typically this involves specifying the internet address of the machine where the database server is located, plus providing a login account name password for database access. And then the client program submits queries to and or updates the database. Okay, so once the connection is established, the program can interact with the database by submitting queries, updates, and other database commands. So in general, most types of SQL statements can be included in application program. And when a database access is no longer needed, the D is missing here, client program closes or terminates the connection to the database. So a program can access multiple databases if needed. In some database programming approaches, only one connection can be active at a time, whereas in other approaches, multiple connections can be established simultaneously. So we'll be discussing about embedded SQL now. So what is meant by this embedded SQL that we discussed earlier? That is, we have a programming language, high level language. Then within that we can embed statements of SQL. Okay. So this there is one EM is here, embedded SQL. So most SQL statements can be embedded in a general purpose host programming language such as COBOL, C, and Java. And an embedded SQL statement is distinguished from the host language statements by enclosing it between exec SQL or exec SQL begin and a matching end exec. Okay, that is for this exec SQL or exec SQL end, begin and end. Okay, and we note that when this kind of statements are seen, the precompiler or preprocessor scans the source program code to identify database statements and extract them for processing. And we can say that the syntax may vary with languages, and shared variables used in both languages usually prefixed with a colon in SQL. Okay, that keep that in mind. So we'll be discussing about this variable declaration in C. So discuss about a variable declaration. So the variables inside declare are shared and can appear, that is while prefixed by a colon, that we have already seen in SQL statements. And SQL code is used to communicate errors or exceptions between the database and the application. So we have SQL code that is used to communicate errors or exceptions between the database and the program. Suppose we have this company database, and we need to declare program variables to match the types of the database attributes that the program will process. And the programmer can choose names to the program variables. They may or may not have names that are identical to their corresponding database attributes. So this is a C program, variables declared, and show C program segments without variable declarations. So shared variables are declared within a declare section. So here, as we can see, a few of these C types or common bindings of C types to SQL types are like this. The SQL types are integer, then small int, then we have real, double are mapped to C data types, long, short, and float. We have double. Here int type is only used, and we know that in SQL we have fixed length and varying length strings, that is char I, char of I, and var char of I. And this SQL types can be mapped to arrays of characters. Okay, these are arrays of characters, that is char of I plus 1 or var char of I plus 1 in C, that are one character longer than the SQL type, because in strings, strings in C are terminated by a null character /0, okay, which is not part of the character string itself. And we know that this var is not a standard C data type. It is permitted when C is used for SQL database programming. And notice that the only embedded SQL commands in this are this begin declare and end declare sections. And this tells the precompiler to take note of the C variable names between, that is these SQL the precompiler will take this SQL embedded statements, that is exec SQL begin and exec SQL end. Okay, and we have what this embedded statements tell, that tells the precompiler to take note of the C variable names between the begin declare and end declare, because they can be included in SQL, embedded SQL statements, as long as they are preceded by a colon. And from these lines we have attributes. These lines correspond to the attributes of the employee and the department tables from the company database. Okay. So these are corresponds to D name, F name, SSN, B date, etc. So that corresponds to attributes of the employee and department tables from this company database. And we have this integer variables, and then we have int SQL code. And as I told you, this SQL code and SQL state are some SQL communication variables. They are used to communicate errors and exception conditions between the database system and the executing program. And we have a program variable loop that will not be used in any embedded SQL statement. So it is outside this SQL declare section. Okay. So this cannot be taken part of this SQL embedded SQL statement. So we will be taking, or we will be declaring that outside the SQL declare section. And we'll see some commands for connecting to a database. So SQL command for establishing a connection to a database has this kind of syntax. Okay, so connection, that is multiple connections are possible, but only one is active. Okay. So we have this syntax that is for establishing a connection to a database. That is connect to, we should supply the server name, then as connection name, followed by authorization, user account name, that is user account information, that is the user account name and password. So since a user or program can access several database servers, several connections can be established, but only one connection can be active at any point in time. Okay. And the programmer or user can use the connection name to change the currently active connection to a different one by using the following command, that is set connection name. Okay. And once a connection is no longer needed, it can be terminated by the following command, that is disconnect connection name. So next we will see embedded SQL in programming examples, that is processing query results using cursors. So a cursor is a variable that refers to a single tuple from a query result that retrieves a collection of tuples. So this is used to loop over the query result one record at a time, and the cursor is declared when the SQL query is declared. And later in the program, an open cursor command fetches the query result from the database and sets the cursor to a position before the first row in the result of the query, and this becomes the current row for the cursor. And subsequently we have a fetch command. So fetch commands are issued in the program, and each fetch moves the cursor to the next row in the result of the query, making the current row and copying its attribute values into the C language, that is the host language program variables specified in the fetch command by an into clause. Okay. And the query variable is basically an iterator that iterates or loops over the tuples in the query result, one tuple at a time. So that's the case. Then to determine when all the tuples in the result of the query have been processed, what we have, the communication variable is used, that is SQL code, or we have SQL state, and that is checked. If a fetch command is issued that results in moving a cursor pass the last tuple in the result of the query, a positive value is returned in SQL code, indicating that no data was found. And the programmer uses this to terminate the loop over the tuples in the query result. So we can use a close cursor to indicate that we are done with processing the result of the query associated with that cursor. So now we'll see what are the database stored procedures. So these are actually program modules that are stored by the DBMS at the database server. So in our discussions of this database programming techniques, there was an assumption that the database application was running on a client machine, or more likely at the application server computer in the middle tier of a client server architecture. And in either case, the machine where the program is executing is different from the machine on which the database server and the main part of the DBMS software package is located. Although this is suitable for many applications, it is sometimes useful to create database program modules or procedures, or we can call functions, that are stored and executed by the DBMS and the database server. And these are historically known as database stored procedures. Although they can be functions or procedures. Okay. The term used in SQL standard for stored procedure is persistent stored modules, because the programs are stored persistently by the DBMS, similarly to the persistent data stored by the DBMS. And this persistent storage or stored procedures has some advantages also. That is, if the procedure is needed by several applications, it can be stored at the server and invoked by any of the application programs. And this reduces the duplication of effort and improves software modularity. Okay. Then executing a program at the server can reduce data transfer and communication cost between the client and server in certain situations. And third one is that these procedures can enhance the modeling power provided by views by allowing more complex types of derived data to be made available to the database users via the stored procedures. Okay. And there has some disadvantages also, and that is, if we are storing a procedure within a database, it is limited to the corresponding syntax of the corresponding DBMS package. So there can be some portability problem for the program for some database server. So we can say it is actually every DBMS has its own syntax, and this can make the system less portable. Many commercial DBMS allow stored procedures and functions to be written in a general purpose programming language. The stored procedure can be made of simple SQL statements such as retrievals and updates, and the general form of declaring stored procedure is like this. So we have create procedure, and we have a procedure name, then followed by the local declarations and procedure body. And the parameters and the local declarations are optional and are specified only if needed. And suppose we need to declare a function returns some values. So a return type is necessary. So the declaration will be like this. A store function will be like this. Create function, then we have function name and the parameters, and we have returns, this return type, then local declarations and function body. And when we call a procedure or function, we can use the call followed by procedure name or function name and the arguments, the list of arguments. Then this SQL persistent stored modules, that is PSQL/PSM. Okay, so this is a part of the SQL standard that specifies how to write persistent stored modules. So this includes statements to create functions and procedures, and it also includes additional programming constructs to enhance the power of SQL for the purpose of writing the code or body of the stored procedures and functions. Okay. So here we can take some examples of branching and looping statements. Then as I told you, this will enhance the power of SQL. So the branching, conditional branching statements will be like this. If condition, then we have statement list. Else if condition, then we have then and statement list, etc. That is the format of the conditional branching statement. And finally we will have an end if statement. Consider this example. This illustrates how the conditional structure can be used in this SQL/PSM function. So this we have a create function here, and look at this. This function returns a string value. Okay, it returns a string value, and then describing the size of the department within a company based on the number of employees. And there is an in variable or in, that is int parameter, integer parameter, that is department number, which gives the department number. Then a local variable number of employees is declared here, and the query select count star into, so here the number of employees is declared like total employees, that is as integer, and the query this select count star into total employees, it will return the number of employees in the department. And the conditional branch in the line, this is a conditional branching statement that returns one of the values, huge, large, medium and small, based on the number of employees. If the number of employees is greater than 100, then return huge, etc. Okay. And end if, that is end of this if conditional branching part. Okay, that is all for this SQL/PS. Thank you.